This is a video to look at the reaction between sodium and chlorine. It is a good example of the formation of an ionic compound. Sodium, which is in group 1, has 1 electron in its outermost shell. Chlorine, which is in group 7 or 17, has 7 electrons in its outermost shell, and the sodium needing to lose 1 electron and the chlorine needing to gain 1 electron to obtain a full outer shell, an inert gas structure, is easily achieved by the sodium transferring an electron to the chlorine atom. Sodium is kept in oil, and so to enable this reaction to occur readily, the sodium must be first cleared of the oil. So we take a piece of sodium from the container and place onto the white tile. I will then clean the sodium by placing it into a solvent which has hydrocarbons which will dissolve the oil and remove the oil from the surface of the sodium. So I take the piece of sodium and place it into the solvent. So we have the piece of sodium in the solvent. Just allow that to clear. Once the oil has dispersed, just take it out of the oil and we remove the solvent. Remove the solvent. There's the piece of sodium. I'll remove the solvent by just simply placing it onto a piece of tissue and making sure that there is none of the solvent left. I'll then place the piece of sodium onto a surface. On this occasion the surface is a brick, so we place the brick into that position there, and the gas jar of chlorine, which has been made up before, is available. You can see the yellow-green colour of the chlorine. I put 2 gas jars just in case the first fails. 2 gas jars of chlorine, but this gas jar of chlorine has been made up and is a dense gas, and so I'm able to put it over the sodium. If we then start to heat the sodium, what will happen to the sodium is that of course it will start to react with the air, but at this high temperature you will get a ball of silver being formed, and at a certain point when it's hot enough I will take off the dense gas and place it on top, and the reaction occurs. At this point I'll switch the fan on. You can see that the sodium was initially reacting perhaps with the oxygen in the air, and then as the reaction changed to the chlorine gas being placed over the sodium, the reaction remained as a violent exothermic reaction, and ultimately a white solid which appears as a white smoke appears. If we leave this for several minutes, the white smoke will sink to the bottom and a white solid will be found at the bottom, and that white solid is of course sodium chloride. The sodium chloride will form a white disc at the base, and that will be, if there were no sodium and no chlorine left over after the end of the reaction, will be perfectly safe to taste. And having left the experiment between the sodium and the chlorine for one day, all of the white smoke has dropped to the bottom of the container, and the sodium chloride has formed a white disc at the base. So if I take the gas jar off now, all of the chlorine has gone, and it would be relatively safe to taste some of the white solid, which would then be sodium chloride. However, there's a little bit of residual white material, which I think in the center, which is probably sodium oxide from the first reaction of the sodium with the air, and therefore on this occasion I'm not going to taste it. But that is a very clear demonstration that two highly reactive elements, sodium and chlorine, combine together by the transfer of an electron to produce sodium chloride, which is a stable substance which is very unreactive.